Hello YouTube, De-bodgery here. So taking this flashlight apart a bit more, I got the board out. So this outer thread here has got this ring around it, which is really just a thread adapter to the narrower part of the body. Then this inside thread inside here has a spring washer and this retainer, which holds the board inside. And so here is the board, and that ring in the spring washer touches this outer trace on here, which is the negative side of the batteries, and then that spring right there is the positive side. So I have added a Jst Connector on here, and the reason why is that right there. So these 5 wires were soldered directly onto that board, and so by putting a Jst Connector on, there's no current in here. I can just unplug it and plug it back in again, and it all fits inside because there's plenty of room, as you can see. You know, the walls are pretty. You know, the walls of that space are this height, and that Jst connector, come on, focus, is well inside that. So over here, that little MOSFET right there will focus. There we go. So that is a D484. And I looked the little bugger up, and she's a 30-volt MOSFET, good for a maximum of 25 amps, and with a shitty high internal RDS of 15 ohms minimum. I'm used to dealing with MOSFETs that are, you know, down there in, like, say, the 3 milliohm range, not 15 as a minimum. Anyway, it had that itty bitty heatsink, which I say itty bitty, you know, look at my fingers. The thing is tiny, glued down on top of it. I'm not exactly sure what good that's going to do, especially in trapped airspace where it's all hot. It's not really going to radiate much. That could have been done a smidge better, a lot better. Alright, so there's only one of those guys, and with just that little tiny heatsink sitting on top of it, I'm going to say there's no chance at all that this was able to deliver 25 amps. You know, it's got a little bit better cooling because it is on a somewhat decent sized pad on the board that goes through the other side. So that's helping some, but let's keep in mind that all this stuff is trapped inside the hottest part of the flashlight. So not really very much cooling in there, if any at all. So really what they should have done is they should have stacked 2 of those LEDs on top. But I have to say that the flashlight that I've got sitting there running, it's still running, and it, you know, starts out and you turn it on with 4 LEDs, and now it's down to 3. So, you know, I'm down to 75% charge or so, you know, according to its little brain. So anyway, yeah, those LEDs are not drawing a lot of current, and that's proven out by the fact that there's one dinky MOSFET in there with one little itty bitty heatsink on it that's doing all the driver work. So really what's happening is the MOSFET is just an on-off device essentially in this use case. So what you're doing is you're applying a pulse width modulated signal to the MOSFET gate. And so the MOSFET turns on and off, you know, fully on or fully off rapidly. And the faster those pulses come in, the brighter the LED is. So that's pretty much how that works. Probably that little dinky guy down here on the board, because this thing does have a charge controller on it. Probably that little chip right down there. That's probably your lithium-ion charge controller. And, you know, here's obviously the USB port, and I'll show you the other side of the board here in a second. And there's your micro USB, which is your charging port. So here is the brains. They have scrubbed the top off the chip, so I can't look it up. But it's very likely something like a microchip's PIC controller, you know, something like that, that they've got a little bit of microcode in. Alright. You have 2 basically DC to DC converters on here. So that one down there, you can see the little inductor and the chip for it. That one is converting whatever battery voltage coming in to a steady stream coming out. So let's, you know, since this is 2 cells in series, that's going to be a maximum of like about 8.2 volts. So probably that's like stepping down, like whatever that is, to like say 5 volts. i.e. what you need at the USB port, is my guess. And then this other one, whoops, I dropped the board. Yeah. And then the other one, which is basically, come on camera, refocus. Those little components over there next to the MOSFET and on the board, those are the control electronics, and right under the Jst connector, you can, come on camera, focus. You can see, yeah, another inductor. So that's the other DC to DC converter, and that is probably the one that, it's essentially the driver for the LED. So you basically have two little tiny switching power supplies, or DC to DC converters, on this board with some control electronics around it, namely that chip right there, and a few other things. Anyway, yeah, not a lot in here. Pretty darn simple, and not very complex. It looks like, where was I seeing those? Somewhere's on here. Those little bank, there they are. So those guys, right there, those are essentially very low resistance resistors, and I believe that they are there for current sensing. So the LED doesn't get overdriven, because you do that to a Chinese LED, and well, let's just face the facts, they burn out. So I think that's what those are about, and as you can see, there's only 3 of 5 there, which makes me think that possibly this board can drive a smidge harder by putting a couple more little low resistance value resistors on there, which is going to make the shunt value total lower and raise the wattage and so on and so forth, and make this board deliver possibly more current. I think that's what that's about. I'm not entirely sure. Anyway, pretty lightweight. I think if I'm going to properly drive like an XHP160 it is not going to happen with this little board, because it just does not have the skookum or the punch or the beef or whatever you want to call it to pull that off. It is too lightweight. So anyway, let's shine down the hole. Alright, so this is not going to work super well. Come on, there we go. I guess that's about as good as it gets. So right there, that's the underside of the spot where those 2 holes are. That's where the wires go through for the LED, and that's the underside of where the LED mounts. Turn this a little bit this way. There we go. Alright, come on camera. Pull that bad boy in. There she is. So that little board right there, that is the back side of the button, which has, the button and 4 little LEDs in it. So anyway, that main chip on the board, that probably microchip PIC controller, is using an input and 4 outputs to drive this whole little mess. And you've got just enough wires for that, 5 wires. So anyway, that's what that's about. That's what drives that little board with the LEDs in it. I tried to pull that out, but I'm pretty darn sure this little brass ring is threaded in, and there is such a low lip on it, there's nothing to grab a hold of, and as you can see, I scratched the anodization off the aluminum. But I tried to get a knife under the edge, I tried turning it with pliers, and it's just no purchase on there. I've tried turning it with my fingers, and it does not move. And then inside it, there's a little thin ring of plastic, polycarbonate probably, that lets the light from the LED shine through. Anyway, not getting that out easily, but you have to remove that brass retaining ring, and then the whole board feeds out through the outside and the wires to the inside. I know that because I can't really show this to you too easily, but come on, pull that bad boy back in again. Focus. Yeah. This lens is super slow at focusing. That little tiny board inside there, it is retained in a flat spot that is smaller than the board. So what you have to do is pull it out the top, rotate it 90 degrees so it's on edge this way, and then you can drop it back through the hole. But you have to get that retaining ring off to pull it all out, and I can't. It's just too small. And there's no like a couple little tiny holes in it that I can purchase something small in so I can turn the ring. I'm just going to really destroy the ring if I try to pull it out. So anyway, I gave up after a while and just said, never mind, I'll see what I can do with it in there. So anyway, yeah, that's almost everything there is to it. Yeah, that hole, you're looking at the underside of this. There's really nothing special about it. This is essentially a hunk of aluminum. There's a little rubber door over where the USB slots go, and that's it. Nothing special. I'd still like to get that retaining ring off so that I can pull this outer sliding section off. I believe that there is just like a couple of O-rings in there. This is not really heatsink. It's more, it's not making metal to metal contact with this inner part here. It's got O-rings underneath it so that it slides smoothly. Otherwise it would kind of scratch this ano up, and there's nothing like that. And then also, being it's the nature of what it is, you'd also want, like, say, thermal grease underneath there so you got heat transfer. So it's not really doing much. This outside part here is a secondary heat transfer, but it's not really a heat sink per se. Well, I think that's probably it. Everything I want to show you about this stupid thing. Yeah, I'm still relatively not impressed.